So you guys were taking notes. We're talking through why this should be review, the regression one over here. We're going to stat to get our list, stat edit, and then for our scatter plot, Jason, you were saying it, go to Y. Okay, so you can go second Y equals, and then you can hit on, like to actually turn on a stat plot, or the other shortcut is Y equals and go up and highlight plot 1. Remember that? What's the nice zoom for our regressions? Zoom stat, good. We'll zoom in on the actual statistical points that we have. So we're not going to do this one. Why? It's in your handbook and it's in your worksheet, and I gave those papers back to you, right? Okay. So do we think that we should be able to get this on our own?
Yeah.
Hope so. Because you would run that, you would get this, you would have your equation for your linear regression. How do you get the actual line in the graph? That's our stat plot. Plug in this formula for y1, right? And then you would have superimposed the one on top of the other. But kiddos, that's not the point of today. The point of today isn't reviewing what we've already done. The point of today is how do we deal with new words. So let me go ahead and zoom in on just one more page so you get a feel for what we're actually doing today. Let me zoom in on it. Take one more page of notes. You don't need to skip any lines for the example. We're not doing that example. That's in your handbook. This is what today is going to look like. And I just need you guys to skip for me. I think just one line should be good. Let me go find my red marker. I'm going to pause just because you guys are just writing down stuff. Okay, number 2 was a vocab. Guys, I've been catching up on your Google Classroom, and some of you are still missing points because you're just putting these down. Check your homework. Are you putting just a little description as to what the vocab are? Please start. If you're not, I don't like taking off points. Number 14 and 20 shouldn't take you too long to check. But I think 14, weren't you just checking that they were inverses, plugging one into the other or the other into one? Did everything undo or get undone? Should have. They both should have been to x. And number 20 was reflecting across the y equals x line, I think, right? This was the one that Jordan was talking about yesterday, the weird one, where it didn't seem to make sense. Why would 1 over x be the inverse of 1 over x? But if you look at the graph, maybe you guys noticed that the function was its own reflection. It was already reflected. What's on one side is on the other. What's on the other side is on the one. Like, it was already reflected. It didn't need to go anywhere. And the math also showed that, because when you do 1 over x, it's just x. The reciprocal of the reciprocal goes back to the original. It was weird, but right. Do you guys all got that it failed? It wasn't invertible? It's a quadratic. It fails the horizontal line test. Yeah? Now, could we find an inverse relation? Yes. But would it be an inverse function? No. Good. I gave you 2 just because it's so weird. You might not have believed me the first time. But when you switched x and y and solved for y, wasn't it itself again? Yes. Look at the graph. It's its own reflection. It already reflects on its own. It doesn't need anybody else. The hard part on this one, I thought, was the domains and ranges. But did you guys see how x can't be 0 and y can't be 0? So if x can't be 0 and y can't be 0, they're the same thing. So when you flip them for the inverse, they're still the same thing. All real numbers but 0 because of the asymptotes. (64) switch x and y, solve for y. Why did they not write it f inverse of x? Is it an inverse function?
No.
Why not? It's 2 different functions. Good. Plus or minus. It's not an inverse function. I know the wording is weird, but it's not an inverse function. It does undo. You plug in, it works. It undoes. It's just not one function. Oh, is that it? Oh, that was quick. Okay. Let me freeze this real quick while I open up the book. Well, let me check first. Do you guys have any questions on evens or odds? No. Oh, we were okay? Okay, so inverse is not too bad. Switch x and y, solve for y. Notation, remember it's f. The -1 means what? Inverse of x. Good, good, good. All right. I was hoping I covered most homework questions yesterday in class, and that's awesome that we were able to do that, and you guys did well in homework. So let's go back to notes, because the more time we can spend on this, the better. I know it's going to be a little bit annoying, but the more time, the better. All right, kiddos. Direct variation. We've already talked about the rest of it. The least squares regression line. There's this thing called the correlation coefficient that says how well the line fits the data. If you have a scatter plot that's like all over the place, a line doesn't really mean that you're going to know for sure what's going to happen. Not that we can ever predict the future for sure, but when the data is really close to the line, it's like I'm this percentage, I have a really high percentage, a really good chance. That's a good way of putting it. However I was going, it was not working out. So you have a really good chance of it actually working out, but if the data is all over the place, if the R values, some of your calculators come up with more than mine does in class. Anyway, but you don't need to know anything else about linear regressions beyond calculator worksheet number 2, okay? Beginning of homework, do a regression, not a big deal. But then the rest of homework, interpret, translate, solve. Let's figure it out. This page and all these, like these 3 pages that are to come, all about interpreting. I want you guys to get out 2 colors, please, if you have them. 2 colors. Can be pencils, can be highlighters, can be pens. 2 colors. I'm going to use, what's up here? I'm going to use purple and yellow just because they're right here. I can't actually hit on these ones. I'm going to use purple and yellow. Okay. I want you to, in each of these, 1, 2, and 3, I want you to box the y's in one color. And I want you to box the x's in another color. Oh, that's not what I want. K is its own little dealio. He's called the constant of variation or the constant of proportionality. If you think about, let's do an example. Area of a circle. What's the area formula? A equals pi r squared. Guess what I can say? A equals pi r squared. I can say that A is directly proportional to r. Did I even talk about the pi? No. So this wording is just telling you about the relationship between the independent and the dependent variables. Oh, I forgot one. Poor little guy. This wording only tells you about the independent and dependent variables. It doesn't talk about constants of variation or constants of proportionality or the pi's or whatever other equals mc squared. Is there a constant in there? No, there's not. Compounding interest. How's that one go? I equals per I is e to the RT. It kind of does. Anyway, you guys probably don't have a lot of these memorized. But the long story short is I'm not talking about the pi's or the different numbers, 2's or 3's or whatever is in front. I'm just talking about the y's and the x. So I want you to come down. You guys already wrote down these 2 examples. Can you put in a purple box, according to the wording, who would be your y's? And put in a yellow box or whatever colors you have. Put in the other color, whatever would be your x. Take a second, read the statements. I want you to color code who would be the y and who would be the x. In there, not talking to me. Color code. Another couple seconds, but it should be fairly straightforward, right? How'd you guys find it? How'd you find the y for the first one? Directly proportional. I would even go one word back to is, and then the y always comes. Yeah. So simple interest, it's the y, no big deal. How about this one down here? This one's a little bit harder because I see varies directly. There is no is, number 1. And number 2, aren't there a lot of words? Yeah. Now, if English is your first language, it's not a big deal. You're like, okay, the subject of the sentence isn't as an object falls. That's a descriptor. The subject would be distance. But if English is not your first language, it gets a little hard. There's a lot of words. So varies directly. The object falls is just describing the main due distance. Now this guy, they actually give us a variable and say, hey, call him S, please. This guy, they don't tell us to call him anything. So we could call him Y, but just a warning, it's going to be hard to attach Y's and X's. It's going to be easier to attach actual letters that stand for what's going on. So usually in financial stuff, if we're talking about interest, it's an I. Almost always. Interest is always an I. Okay, who is our X's? Who are our X's, I should say? Amount of the investment. So amount, that's good, right? But don't we technically need the investment, right? Okay. So how much was invested? And then down here, what's our X? Ooh, if you just do duration, you're wrong. Why? Square of the duration. Just be careful. Of the fall is just an adjective clause, or a prepositional phrase. They're just describing what's going on with duration. As that's just kind of like furthering our wording. But square, that's important mathematically. So it's not just T, it's T squared. Right? And then amount of the investment, you might be like, I, no, A, no. In financial formulas, we usually call this P for principal. It's like the initial money put into the account. So how would we write these equations, guys? Any ideas? If the equation, the overall equation we can use for direct proportionality, puts the independent, times the constant equal to the dependent, well then who should go first? I. And then the is equals, and then we need a constant, K, because we always have to leave room for this relationship. There might be some sort of constant that's involved. And then P. Dun, 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 dun. Was that hard? Hopefully not. I equals K times P. So what's this guy? S equals KT squared. Something that you guys have talked about probably in the past, maybe Algebra 1, I don't remember, with direct proportionality or direct variation. One quick idea having to do with him is as one quantity. If one quantity goes up, the other goes up along with it. Direct proportionality, if one goes up, the other goes up. If one goes down, the other goes down. What can be an example of this? If one goes up, the other goes up. Say it one more time, Matt. Hopefully. Hopefully. If you're actually working a job that actually gives you a paycheck, then yes, that would be true. You could also say, as time goes on, your age goes up. You could, for children, you could talk about, and I think this was in calculator worksheet number 2, as their age goes up, for like little kids up to it, like their weight goes up, right? Babies should grow. I mean, if that doesn't happen, something's wrong. What would be an inverse relationship? Let's talk about the other type of variation. I'll give you a little bit of time to write this down, but as you guys write down inverse variation, how is that different? As one quantity goes up, the other quantity goes down. As one quantity goes up, the other quantity goes down. As the temperature in the summer goes up, people's patience levels go down. Maybe that's not entirely true, but you get the idea? Yeah, as soon as you drive it off the lot. Well, but then some of you are like, what about classic cars? Anybody thought about Astro vans are going to be the new classic car of like the next decade? It's like a minivan, like a awkward old one from like the 80s or 90s. If you guys go to the car show, there's a car show at the Tampa Mall on Sundays. Is that right? Sunday morning early? I have a friend that goes there before church with like her brother. But yeah, she's like, the classics are now just the cars that were beaters when we were. I mean, that's technically what they've always kind of been, but now it's like they're not even cool. Anyway, it's a weird thought. What's going to be the classic cars for the next? I mean, the classics, like the Mustangs and the Corvettes, like those will be classics, but the new, I don't know, it's weird. So some cars are maintaining value or regaining value. I'm like, really? Who would pay for that? But anyway, generally, Matthew, yes. For cars that are like 10, 20 years old, as soon as you drive it off the lot. As time passes, car value goes down. As time passes, land value goes up. It depends where you live. That doesn't really work. For some. There's a lot of exceptions, right? But yeah. As time goes by, minimum wage goes up. But that would be a direct relationship. It's not a healthy direct relationship, but that's okay. As what? Oh, as your play goes up, your grades go down? As your free time? As Netflix watching goes up. Test grades go down. Anyway. Depending on how you spend your free time.
The space in your fridge goes down.
There you go.
No, the space in your fridge goes down.
You guys have color pens. We're going to start highlighting stuff. But yeah, you get the idea of direct and inverse. Direct, like as one, they work together. They work in tandem. The rising of one includes the rising of the other. The falling of one is the falling. Inverse, they're working against each other in a sense. I'm going to grab out my purple and my yellow just because they're here. So, you guys see your Y's, right? I'm going to go back and get my X's. What? Are we okay? This is a sign of friendship and that she's okay to be mocking you, right? Oh! I'm just checking. Because depending on who said that, it would have been appreciated. But Lauren was smiling. I think we're okay. Now, no. Let me save this. I have something else to show you guys from the beginning of notes that I didn't show you, but we'll get back to that in a second. Right now, it's not too bad still, right? So question, who's purple? Who's the Y? Demand. For a product, that's just describing. Demand. Supply and demand. Economics. Ooh, this is getting intense. Demand. Varies inversely. There's our wording, right? Who's our X?
Price.
That's the price of the product, just describing. What do you guys want to make your variables? Do you want to really use Y and X? D? Sure. D sounds good. P? Yeah, we can use that, I suppose. So what would your equation be?
D equals K over P.
Yeah, I heard multiple ones of you getting there. So far, just interpreting what's being given to us and translating that into a model. A model just means the equation. Have we used any of these models yet? Have we actually figured out what the whole equation is with the K plugged in, giving clues? No, we're just interpreting and translating right now. Inverse variation. We have two more. Oh no. Oh no. Let me dual page for a little bit because some of your eyesight, you'll be good seeing both. Hold on, I'm bringing it back down. Combined variation. Now, guys, on this example, what are we being faced with? Am I taking a lot of time on these slides? No. Why? Because they're not super complicated. But wait, look at that example. If you actually write the whole thing out, how long is that going to take? Now pause. Remember how in homework, keep writing, of course, don't totally pause. But in homework, don't I tell you to summarize the directions in the problems? The goal is that you're reading and you're pulling out the most important stuff to the directions and the most important stuff to the problem and then going from there. Do you think in your notes you need to write this whole paragraph of information? No. Couldn't you pull out the most important wording? And maybe you're not actually writing of a copper wire carrying electrical current. Maybe instead you're just writing resistance is directly proportional to. Shorten it, because as you shorten it, that's what you'll do in your homework. You'll say, okay, what's the most important wording? Hey, that's exactly why I know this equation. You're going to want to shorten, to summarize, to do the short and sweet version of these problems, or else you're going to be writing forever. And some of you I know are so meticulous, but I do not give you brownie points for writing every word. I don't judge you either. Like, it's not, if you want to do that, it's okay. But you don't have to write everything. Combined variation. Where are boxes? There are no Y's. There are no X's. There's no wording. Because what do you see in here? The wording from before is directly proportional to, what else do you see? Okay, so hold on. We got to think of our main players, right? Who's going to be your Y? You guys agree with resistance? What comes before resistance? Did you need to write down everything else? Not really. Not for just interpreting to get to a model. So the Y comes before the wording. So resistance of a copper wire carrying an electrical current is directly proportional to, okay, what's X? Now here's the struggle. That is an X, right? But this isn't the only quantity that is being measured. What else is there? And there's two different relationships, directly proportional to length, inversely proportional to cross-sectional area. Now hold on, pause. Let's figure out all of our variables, which this could be what you do in homework. You could say, hey, resistance, I'm going to call him R. Length, he's a big player, I'm going to call him L. Cross-sectional area, maybe call him A. So R, directly proportional to L, inversely proportional to A. What do you guys think? How do we do directly? K times. Good. But K isn't just times L. K is also divided by A. How do you do both at the same time? Times L divided by A. Dun, 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 dun. Does that make sense? Combined. Combined variation says, hey, there might be more than one relationship going on. And this is a true relationship. Resistance with copper wires carrying electrical currents. As the length goes up, the resistance goes up, but as the cross-sectional area goes up, the resistance goes down. So it's actually directly proportional to one and inversely proportional to the other all at the same time. Yeah. Last one. Go ahead, Jordan. You promise really? Can you see it? Good? The last one, if you guys are starting to get ready, it's called joint variation. Jointly related, joint variation. Okay, this one does have some equations. I can't really make them too much bigger. That's a bummer. Let me zoom in. I think we should be okay. Okay, joint variation. Z, why do we have Z? Well, because now we have multiple variables going on. But still going to be a similar idea in that you don't have to necessarily memorize the letters. That's not the point. The point is the location. So Z is still our guy that's depending on these other quantities. So he's like the Y of the other ones. But instead of just having one variable, as you guys just saw, we might be having more than one variable. If we have more than one variable, working the same way, we would say working jointly with the other. We can call it joint proportionality. Or joint variation is a better way of putting it. Then we're just going to put them together. So as you guys are writing this one, once again, the example has a lot of wording. Try to shorten it without losing any of the meaning. For instance, I'm not sure you have to talk at all about the object as you're writing down this example just to get the model. So as I read it, I see kinetic energy varies jointly, mass, and square of velocity. That's shorter to write. Has anybody already identified who their Z is or who their purple box is? Yeah, kinetic energy. Varies jointly with mass. But if you go straight to velocity, what will you have missed? Okay, so the square of the object's velocity, right? So it's good to shortcut, but we can't lose any of the important information along the way. It's a life lesson in that. So E, yeah, they gave us the actual variable, right? E is equal to, where's your K? Mass and velocity squared. Took a whole class in college called mathematical modeling. It was basically a text word problems, absolutely no lessons. It said, hey, use all of your former training in math to figure out how to do it. It was brutal. This is so much clearer. Okay? All of the word problems fall under these categories as far as what their models, how their models come about. Okay? So don't be stressed out by the words. Some of them are a little weird. I might put a quick comment on the assignment about the ones where it's like, try your best, but don't stress about these necessarily, to try to help you focus your attention tonight. But so far, guys, all we've done is interpret and translate. What else do we need to do? Solve. So, what do we see? Do we see wording? Yeah. Can we come up with a model just from that wording, not even pay attention? This is important. You should have written it down, like directions, problems, etc. Here's wording. What model can we get? No. Don't talk about that. What model can we get? What would the model be? What would the equation be? Okay, let me pause. Give people a second to write down the important information. But yeah, from the wording, y varies directly with x. Okay, we know the model is y equals kx. Solve the model. What? We already did. No, you didn't. K is unknown. So substitute. That was weird emphasis. Substitute. Where's 8 pi going to go? Where's 4 going to go? And if you plug in for y and x, who are you going to solve for? So when I plug in my clues, what I would call it, anybody watch Blue's Clues? Whatever. If I plug in 8 pi and I plug in 4, pretty quickly, hopefully we can solve. There's the model. No, that's just k. Who's the model? The model is the equation with the k solved for. P.S. Couldn't this be circumference? Circumference is directly proportional to radius with a constant proportionality of 2 pi. Maybe y is c and x is r. Anyway. This is the basic solving. They give you wording, come up with a model, plug in your clue, solve for your k, you have your model done. Could that be the end of the problem? It is in this one. Couldn't they then say, oh, once you have the model, what's y going to be when x is? Sure, they could ask me more information now that I know my model. So who knows how far this will take you in the sense of how much your problems will be requiring of you. But once you have your model, you can use it to do whatever they ask. So how is this one different or weird? They're telling us to choose. Oh, they didn't give us wording, they gave us points. Can we use what we were talking about just a second ago just to even think or guess which one is right? What do you see about the points as x goes up? The y goes up. Which relationship is as one goes up, the other goes up? Yeah. So we're going to guess this one. How can we double check that we're right? What if we plug in and see if it actually works? So if y is 2 and x is 5, what would k end up equaling?
2 over 5.
Yeah, this would end up getting us that k is equal to 2/5. Will that work for the next ones?
Yes.
Because 2/5 times 5 would equal 2. That works. If I was to plug in 10, that's 1 and 2 and 2 is 4. That does work. If I was to keep going, plugging in 15, plugging in 20, guess what? It's going to keep on working. The K is going to be 2/5 every time. Yes, directly proportional. Solve the model. Oh, I just did. What's the model? Y equals 2x over 5 or 2/5 x. Same thing. Multiplication by 2, division by 5. Ooh, what about this guy? Now, do you guys think that maybe I summarized this just a little bit already?
Yes.
Yeah. Could have been a lot longer. What I pulled out was simple interest directly proportional to investment. What were the variables that we used just a little bit ago for these guys? Who's this guy? I. And if he's I, well, what's this guy? Yeah. Anybody remember the word for it? Financial stuff. Investment. Principal. Principal. Find the model, no big deal. Directly proportional. Which kind of equation is that? So apply that. I'm not done yet though, because what do they give me right here? They gave me stuff to plug in. That's our clue. So investment, who's that? Wait, where does he go? Investment. Now I got confused. Who's who? Is that I or is that P? Good. The amount of money you put in, $6,500. Interest is $211.25. That looks like 24. I apologize. 211. Could we solve for K? Yes. Are you using your calculator in this assignment? Yeah, you are. Look at those numbers. Find the model. What is it? 0. Yeah, I'm just doing long division in my head. Someone's bound to have a calculator close, don't they? What do you got, Matthew? 325. Got it. Done. What if they asked you to then go ahead and say, what would have happened? What interest would you have gotten if your investment would have been $8,000? No big deal. Plug in 8,000. What if they asked, what would you need to invest in order to get interest at $500? Plug in 500 and solve. So you might need to use the models, but if you don't find the models to begin with, we're just in a whole lot of trouble, yeah? Do we have anything else? Oh. You guys want to see what I have at the very beginning of notes? Sometimes you see a word problem and you think something like this guy. But should that be this homework? No! Because we've talked about what you're supposed to be reading, what it means in terms of math, and then what you're supposed to do with plugging in. So hopefully, even though this one, maybe. No. It doesn't make sense. That's the point. To some people, word problems are a whole lot of gibberish. You have no idea what's going on. And these ones, we have talked about it in class. We've gone through how to interpret models, equations, how to take clues and plug in to find K, and then how you can go ahead and use it after the fact. Sound good? Okay, do you need to get bogged down writing paragraphs of problems and directions tonight? No. Summarize the short, sweet, but don't lose any of the important information in the process. Sound good? All right, get out of here. Test is on Friday. Get this homework totally attempted for tomorrow so that we can review tomorrow. Bye, guys.